Okay, here we are back in this problem again. Started to get a little too long on that last video, so I shortened it to this one. Okay, now the key to this problem is to avoid messy algebra. Let's write this as a piecewise function, this absolute value function, because absolute value functions are essentially piecewise functions. You can write them that way. So here we have the x minus 3 absolute value is the opposite of x minus 3 when x is less than 3. Okay, so think about that. For values less than 3, let's say for x equals 2, for example, you'd have a 2 minus 3 over here, but you want to keep it positive. So in other words, you'd always have negative values in here as long as x is less than 3, and then you'd make them positive. Okay, so how do you make something the opposite? Well, you just put a negative in front of it. So that's what I did. I dropped the bars and I wrote negative x minus 3. Okay, so that will guarantee that this expression that I have right here will be a positive number. I'm putting that negative in there. So you might call it a trick, but okay, now on the other side of the function, when x is greater than or equal to 3, well, this expression already is positive, so you really don't need the bars in here. I mean, when x is 3, it's a 0, that's fine. But as long as x is positive, then whatever x minus 3 is, that's what the absolute value is for that expression. So I can just keep it this way. Now I can use these two expressions to calculate my two-sided limit by calculating the one-sided limits. Okay, so now remember, they have to be equal. The limit from the left and the right have to be equal in order for the two-sided limit to exist. And I did my calculations over here. Notice I take my difference quotient. I take this first expression right here, which I just wrote this way. Okay, I wrote it as 3 minus x because that's the opposite of this quantity. And minus a 0 because f of 3 is 0. Okay, you can use whatever expression you want to calculate that. F is 3, it is definitely a 0. Okay, and then I work down here. Notice I just get a negative 1. And then over here, second part, I'm going to work with the function where x is greater than 3. So that would be this piece of the function here. So I'm using this piece. And notice what happens in my quotient here. I just end up with a 1. Now again, you might be saying, well, f of 3, that's what I use right in here. Calculate f of 3. I am actually using this portion right here because that's corresponds to this domain. X is 3. So I needed that in both cases. In any case, after I do the arithmetic here, now I've got some bad notation here. Let me fix that. I don't want you to get lazy like me. This equals here is actually not supposed to be there. It's my mistake. This is one expression. Okay, this is the limit of this expression as x approaches 3 from the left. The same thing down here. It's one expression. Okay, so now these are different. This one and this one are different. Therefore, the two-sided limit does not exist. And the two-sided limit is our derivative. That's the derivative of the function at that point. So we've shown that since that limit doesn't exist, it does not have a derivative. That's what we mean by saying it does not have a derivative. It means the derivative doesn't exist there because this limit doesn't exist. Okay, so that's some of the terminology and how we use it. Okay. Now here is a pretty typical problem. Authors throughout the text is always asking us to write equations of tangent lines. Just, I believe it just wants to reinforce the idea that when we calculate a derivative, we are actually finding the slope of the tangent to the graph at a given point. So we're going to work through this one now, and this should wrap it up then. So to find the equation of the tangent, remember you can use y minus y1 equals x minus x1, as long as you have an ordered pair and slope. Well, we need to calculate the slope of the tangent to make this work. So let's go ahead and calculate that. The slope of the tangent m will be this limit. And you can use whatever form you want. I'm going to go with the delta x heads to 0. You could have used the other form, f of x minus f of c over x minus c. We could use that form if you really want. It's about the same amount of work either way. So we'll do it this way. We'll take the f of x plus delta x minus f of x over the delta x. Okay, now it's going to be a little algebra in here because of that function. This would be x plus delta x raised to the third power plus a 1 minus x to the third plus a 1 over that delta x. So this is going to be a little bit of work for you, but you get through it. So you're going to have an x cubed, plus a 3 delta x squared plus 3 delta x squared x plus delta x cubed. Okay, so notice how powers went down: x squared, x cubed, x squared, x, and then x to the 0. Okay, so you'll have to do that expansion. I left out a few steps, but it's nothing that you can't do with a little bit of perseverance. You can get that. All right, so let's see where this takes us. We do have a couple cancellations. This term goes away with that one. The 1 and the minus 1 are gone. So I'm going to factor that delta x out. Three delta x plus delta x squared. And you have the delta x down here. Okay, so you get a little cancellation here. And that divides out. And then, let's see, I have a little more room here. Okay, so we finally have this last expression. Which is 3x squared plus a 3, let's say 3x delta x, and then a delta x squared. As delta x approaches 0, we just have 3x squared. Okay, now we were trying to find the slope at this point, -1, 0. So, now technically speaking, I mean, up here I call this m, but it is a function. This what we have here is f prime of x. More specifically, it'll be m once we evaluate it at different values of x. So right now we have the derivative function. I was getting a little ahead of myself by calling it m, but ultimately that's what it will be. So we have f prime of x is 3x squared. Now we calculate m to be f prime of -1, which is going to be a 3 times -1 squared, or just a 3. Okay, so that was at the point -1, 0. All right, so here's our slope. It's 3. That means if we go back and work with this form from the top, we have now y minus 0 equals 3 times x minus -1. So y equals 3x plus 3. And that is the equation of our tangent line at that point right here.